Hello everyone, my name is Daniel and I'm a programmer and an artist, and here's a sneak peek at some new nodes that I've been working on. But what I wanted to do today was, yesterday I saw a comment asking about how you could make braided rope or cable, which I thought could be sort of an interesting node group, and I don't think it should be too hard. So I thought maybe we could just try to make that node group and do sort of a tutorial out of it. Alright, so the first thing we need to do is add a curve, because we'll want the rope to be made on a curve. I guess before we start, I should kind of explain what I'm thinking of doing. So what I'm thinking of for this rope here is not like a 3-strand braid, but where you have a bunch of small fibers woven together into sort of a fabric tube that goes around a core that's a really strong bunch of fibers. So like a climbing rope. Anyway, to be able to make that, what we need to do is to create a woven pattern that's circular that we can extend along a tube. So the way I'm thinking of doing that is creating a bunch of twisting strands that twist in opposite directions. But then we need the rate at which they twist to be right so that they always intersect at a vertex. And so we should be able to do that by knowing how many strands we have and controlling the rate at which we twist them. And then once we have those strands that twist in alternating directions and intersect at vertexes, then wherever those two vertexes are intersecting, we need to move one of them up and one of them down, or in and out from the cable, so that we create the woven pattern. And then we need to alternate which one goes over and which one goes under for every other time they pass each other. So it's going to involve a lot of index modulo 2s to be able to select every other vertex of a strand and stuff like that. So that's sort of my idea. I'm sure that's probably doesn't make sense without seeing it, but I guess all I'm really trying to say is I have an idea of where I want to go with this. So the first thing we want to do is create a modifier, and we want to go to edit that. We want this to work on any number of curves. Let's just make it straight for now and add a second one so that we can see if it's working on more than one curve or not. First thing we're going to want to do is create the twist, and to do that we need to know how many strands there are. So let's create an integer value for the number of strands. Strands. And then we're going to want to set the tilt of the curve. And we're going to want that to be 2 radians, 360 degrees. Divided by the number of strands, and strands should be set to like 6 or something. Something like that. So this value here, 360 degrees divided by the number of strands, is the number of degrees we need to rotate to go from one vertex on a circle to the next vertex in a circle, if that makes sense. So that if you have something twisting and it's going this way, and it hits this point on the second one, if you have an alternating twist that's going the opposite direction, you don't want it to miss and be over here. You want it to end up at the same point so that when you do your offsets, everything lines up. Hopefully that makes sense. So then we need to increase the tilt for each subsequent vertex along the curve. And to do that, we need points in the curve, so we should resample the curve. And that should be a length, and we should expose this value. We could call this tightness, twist tightness. So now we need to calculate. Basically what we want to do is we want to multiply this rotation value we came up with by the index. Except we can't do the index because the index is going to go up along this curve and then continue over here and continue going up. So we need it to reset to 0 when we go to the next each. So if we throw print values on here, you can see that this one starts at 0, but this one starts at 21, which isn't what we want. Actually, it would probably work anyway because it doesn't really matter what rotation you start with, because as long as it continues by one more each subsequent one. But we're going to want to know the total number of points in each curve anyway, so we might as well accumulate it now. So the way we can do that is by using accumulate field. We want it to accumulate an integer. We want to accumulate the value 1. We want to group it by the index, but we want to evaluate the index on the domain of the spline. And then we want to take the trailing value from that and multiply our rotation by it, and then set that to be the tilt. But we also want to, ideally, we could tilt this curve as well. So we should add the original tilt back in. So that we can still control that, so that we can tilt our twisted strands, or twist our twisted strands along the length of the curve. All right, so that is rotating in the clockwise direction. We also need one that rotates in the counterclockwise direction. We can also, while we're at it here, we can capture this total value, because we're going to need to divide by that later. And if we want it to show up in a mesh that we create from the curve, you have to capture it on the curve. So anyway, so this curve is twisting in the clockwise direction. We want a second curve that twists in the counterclockwise direction. And to do that, we just need, let's create a bit more space here. We need to multiply our rotation value by -1 before we add the original tilt. And then that will be our clockwise and counterclockwise curves. Now, we want to create strands going along the curves. And I think the easiest way to do that would be to convert this to a mesh using a curved circle as the profile. So we'll add a curved circle. This resolution should be our strands input. And then we can expose the radius so that we'll call this strand radius. Let's put strands above strand radius, single value. So that way we can control the overall size of our whole rope. Actually, it's not strand radius. It's like, should just be, it's just like radius, because the strands will have their own radius later. So then we want to do curve to mesh. And that will give us this result here. Oops, that's not right. 6 strands. Oh, it is right. So then you can see we have these edges that sort of twist around the curve, and by adjusting the tightness, we can control how spaced out those are. So then what we want to do is we don't actually want all of these edges that run around the curve. So we want to figure out a way to delete those. And if we inspect how curve to mesh works, we can look at the indexes of it. And we can see that the indexes of the edges. So that if we then inspect the indexes of our edges here, we can see that the indexes of the edges, the first one starts here at 0, and it continues wrapping around the curve like this, and it goes all the way to the end, and then it does all of the rest of the edges that run the length of the curve, and then after it's finished all of those, it comes back and starts doing these loops that go around the curve. And so we can delete all of the edges whose index is greater than the number of strands times the length of the number of indexes in the curve, which is why we need the total. So if we do delete geometry, we want to delete edges. We also need this to work on the multiple curves, so we want to do an accumulate field. We want to accumulate on the edge, and we want to accumulate on the edge, and we're going to accumulate by the island index, so that each mesh that's from a separate curve will have its index start at 0 again. And then we need this total value here. We want to multiply that by the number of strands. Strands. And then we can say if the trailing value is greater than the number of strands times the number of points in our curve, then we want to delete those edges. And then I think we want to do, if we want to add or subtract 1 from this. Because it's points and we were talking about edges, so we have to subtract 1 so that instead of counting the points, we count the edges. And then we still have 1 edge there, so it must be greater than or equal. All right, so now we have our strands. We need to do the same for the other curve. So let's go ahead and make a copy of this. And we'll make a copy of this. So now we have our clockwise and our counterclockwise. So now we want to weave these together. So then what we want to do next is we want to move some of these points closer or further away from the original curve so that they can weave over each other. And to know which points need to move which direction, we're going to need to select them, and we can do that using the index modulo 2 in a bunch of different ways. So let's add the index in. We want to do modulo 2. Let's add a draw points in here so we can see a selection. And let's do modulo 2. And you can see that selects every other strand. So we have this strand selected and this strand selected, but not this strand. So that'll be useful. Then we also want to select, we want to be able to select like this set of points, but not this set of points. So every other ring, if that makes sense. And so to get that, we just need to divide the index by the number of strands. So I'll do divide by strands. Then we need to floor that so that it turns it into an integer. And then if we do modulo 2 on the index divided by the number of strands, we get every other ring. If we then subtract that from 1, then we'll get the opposite. So now we have first ring, second ring, etc. So now we want to, for each strand, select the opposite. So for example, say this is the first strand, we'd want to select this point. And then say this is the second strand, we'd want to select this point. But then on the third strand, we want to select this point again. And so we can do that by using our strand modulo that selects every other strand to control a mix node that selects between our select first and select second modulos. So put this into a mix node, A, B, and then the factor is our strand. And that will get us this. So we have 3 from the first ring, and then the opposite alternating 3 from the second ring, and so on. So now we need to calculate a vector that will allow us to move these points in and out towards the center of the curve. And to do that, we actually need to know the position of the curve. So let's capture that back when we knew what it was. So we'll need a vector. That should just be the position. Capture it on the point. Then we're going to want to subtract that. And bring this over here. We're going to subtract it from the position. Then we're going to want to scale it. So that's now a direction vector from the new position of the expanded to mesh vertex from the original vertex of the curve that spawned that circle, if that makes sense. And then by scaling it, we can move it to the center or back out to where it was originally. Scale. No. Scale. So 0 should leave it exactly where it is. We can do a set position. Offset should be this. And then if we look at that and scale this, it moves in and out from the center. So now if we have our alternating pattern, if we multiply that by some number, let's set it to like 0.1 and expose that. This is going to be the weave strength. And then that goes in our scale value. Now by controlling the weave strength, we move every other point alternating to the center. All right, so now we need to do the same thing, but we want to do it for the opposite set of points on the other curve. So let's make a copy of this. And we're going to need a copy of the mix node and the multiply. And all we need to do is swap which of these goes in the A and B sockets of the mix node. And then we can connect that to the scale value of the second curve, which is this one. Then we can join those together. We can try to join those together. All right, now I think we also need to offset these by 1, because I think this point should be over here. So back here where we make the curve, let's go ahead and just set position on the profile curve. Then we can just expose that to a combine XYZ. And this, affecting the Z value will offset along the curve. I guess to make it less distorted, it would probably be good to set the position of the other one as well. And then we'll just expose this value to the input, and we'll call this twist offset. And we'll make that a factor between 0 and 2. Multiply that by -1 and put that over here. And we should multiply that by the tightness so that it's relative to the resolution of the curve. All right, so now if we adjust this offset value, we can line those up like that. And we should set the default for this to 0.5, I guess. All right. Now I also would like, this is pretty good, but I think it'd be good if the outer points moved out instead of only the inner points moving in. So to do that, all we have to do is here where we multiply our mask by this strength value, we can change these to multiply add. We can multiply our strength by -0.5, and then we can add that to the result. So now we move the inner points in and the outer points out simultaneously. So I think that's a pretty good pattern. Now we just want to increase the resolution of it. So to do that, we should convert it back into a curve. To curve. Then we can set the resolution of the curve. I think like 4 is probably a good value. Let's expose that. We'll call this strand resolution. And then we can set the radius. Something like 0.05 is probably good. We'll expose that. Should be strand radius. Those should both be single values. Resolution, max shouldn't be too high. All right, then we wanted to set the type of spline to be a Catmull ROM. Those will just smooth everything out. And then we want to do back to a mesh, curve to mesh, and we want to do a circle again, curve circle, and then Turn that down. This should be exposed as well. I'll call this, well, this should be the strand resolution. Maybe we'll call this weave resolution. So it's kind of interesting. It looks like I got that not quite right because it goes over 1 and then under 2, which I guess is fine. But it doesn't look like it quite lines up as well as I'd hoped. But it kind of gives you the idea of a braided rope. And you can twist it, all of that. Scale it down. So I don't think it's quite perfect, but that works pretty well. Obviously, if you wanted to texture it and stuff, instead of just doing curved mesh here, you could add a solidify curve. You could set materials, all that stuff. I wonder if you have to delete some of the strands or something. Although it's pretty consistent, it doesn't look like the pattern ever breaks, so that's good. But there's obviously some clipping sort of issues going on. Anyway, that's what I thought of off the top of my head. I'm sure with some more tweaking, it could be improved quite a bit. I'll put this blend file up on my Blender experiments page if you want to download it and check it out. If you think of a way to improve it, I'd be interested to know. And other than that, that's all I've got for this one. Thanks for watching.